Alright guys, so these are all the examples I had you try. I'm going to go through them with you now. So, in this first one, we are simply just simplifying the root. It's a square root. I know the square root of 36 is just 6. I know the square root of anything with a power. I can basically just take 2 and divide it into that number. And so since it goes evenly twice, I have x squared that comes out. Nothing is left in. So that is your final answer. Similarly, on this next one, we're taking a square root, and there's no numbers, just letters with exponents. And so Logan found that super nice trick for us. Whatever the root is, I can just divide that by the power, and if it goes evenly, everything comes out. No letters are left in. So like 80 divided by 2 is 40. 50 divided by 2 is 25. Evenly, so no root anymore. Root is gone. Okay. Example 3, we're still just simplifying, but now we're going to take a cube root. I don't know the cube root of 32 off the top, so I'm going to birthday cake that. Now it is a negative 32, and because it's an odd root, I can take the root of a negative number, and I want to take it out if I can. So I'm going to consider the negative after the fact. So 2 is a prime number that can go into 32 16 times. 2 can go into 16 8 times. 2 can go into 8 4 times. 2 can go into 4 twice, and 2 can go into itself once, and you get your birthday candle at the top. Now, to consider the negative, I have to put in an odd amount of negatives. So I can make 1 2 negative, or 3, or all 5. Now I'm going to stop at 3 though, because I'm trying to make groups of 3. So if I have a group of 3 negative 2's, then I can take the negative 2 out, and the 2 positive 2's will stay in. And I don't want to have a negative in if I don't have to. So I have negative 2 that comes out. I'm going to leave a little space because we might have a k that comes out. Cube root. But I definitely have some 2's that stay in. I have 2 2's, so 2 times 2 is going to be a 4 that stays in. Now with all these letters with exponents before, we take the number outside, like our index number, and divide it. So like 2 divided by 80 was at 40. I'm going to do the same thing here. So 3 goes into 5 once, so k to the first power comes out. But I have 2 left over, so 2 k's have to stay in, so k to the second is still in. Sorry, I didn't mean to space that out so much, but you know, it's all good. Okay, example 4 is ramping it up a little bit. We're still just simplifying, but now we have some multiplication. The reason that multiplication can be tricky is because you can do it in either order. Like I could multiply 4 and 18 right now, and then just birthday cake once, but then I'm dealing with a really big number, and so I rather just birthday cake the 4 and birthday cake the 18 because they're easier numbers. And then I'm going to look for groups of 3 amongst all the numbers that I get on the outside of my cake. So 2 goes into 4 twice, 2 goes into 2 once, birthday candle. So really what I'm doing here is I'm rewriting this as a big old cube root, and now I got 2 2's for the 4. And with the 18 I'm going to take a 2 out, so I'm 9, 3 out, 3, 3, birthday candle. And so then I can rewrite the 18 as 2 times 3 times 3. And so I didn't multiply the 4 and 18, I broke them up and smashed all those prime numbers together, and I'm looking for a group of 3 because we're doing a cube root, and I have a group of 3 2's, so a 2 comes out, but the pair of 3's have to stay in, so it's going to be 2 cube root 9. Okay. Example 5. Same idea with division as is true with multiplication. Like with multiplication I can multiply the numbers right now, but they get big, so I don't like to do that. With division though, your numbers are getting smaller, so usually I do like to divide, and they're both the same root, so you can. And 2 does go into 18, so like I'm just going to do it. 2 goes into 18 9 times. And then the x's can divide, like you have 5 x's on top, 1, 2, 3, 4, 5, and then 1 on bottom, and so like 1 and 1 divide out, so you're left with 4 on top. And if you're still a little weirded out by like the exponent rules, we're going to practice that next week, so don't freak out. Now there's no y to divide with the y on top, so that y is going to stay the same. So now that I've divided, it's actually way easier to take the square root, because I know the square root of 9 is 3. The square root of x to the 4th, so I can divide the 2 by 4 and 2 will come out. None are left in. But 2 does not go into 1, and so that y is going to stay in. Final answer. Because I don't have any roots in the bottom, I do need to consider that with division. But there was no denominator left because it fully divided out. Okay, so then the new stuff, we talked about adding, subtracting, and kind of foiling. So when we are adding or subtracting, we have to have the same index, and they're both square roots. And we also have to have the same number inside, and they're both 7s, and the 7s are as small as they can get because we do want to simplify. So that means I can add, and you're going to have some root 7, and you just add the numbers in front, so 2 and 3 for 5 root 7. Easy, easy. Example 7, maybe a little trickier. They're both square roots, so I can add them, but they don't have the same inside number, so I kind of can't. And 7x is as small as it can get, but 28 is pretty large, and so I think you can birthday cake the 28. Like 2 goes into that 14 times, 2 goes into that 7 times, and then 7 is prime, so birthday candle. So I'm actually able to take a 2 out, so we can rewrite this. The root 7x at the front stays, but then I have plus. I can take a 2 out, but the 7 stays in, and I can't make the x come out because it's to the first. But that's actually a good thing because then the roots are identical, so I can add them up. And I just add the numbers in front, and there's a 1 and then a 2 for 3. Okay, now the last example I gave you, the issue there is that you have a root in the bottom, and you can't have that, so you have to rationalize. And it's one of those tricky rationalized ones because it's not just one single number, it's 2 numbers. And so this is the one where you have to multiply by the conjugate, which is the same 2 numbers except the opposite sign in between, so not a minus but a plus. If I do that on the bottom, I have to do that on the top as well. Now on the bottom, you're really going to FOIL, but what always happens with a conjugate pair is that the outer and inner terms will just cancel because this is going to be 2 root 3 and negative 2 root 3, which is 0. So you can really just do first times first, so 4, and then last times last, which is going to be negative root 9. And guys, I kind of like to finish a thought first, so like I go through and I do the whole denominator, and then I go back and do the numerator. So the square root of 9 I know is 3, and so we end up being 4 minus 3, so just 1, which is kind of nice because that means I don't really need to write the denominator, and there's no root in it, which was kind of the whole point. Now going back to my numerator though, I have one number times 2 numbers on top, so I really have to distribute that. So we're going to get 10, because 5 times 2, plus, now the 5 and 3 I can actually multiply because one's outside, one's inside, so just kind of smash them up. And I really can't add them because this is a root 3 and that is not a root 3. And so this is just going to slide all the way down. And because it's over 1, it's really just 10 plus 5 root 3 as your final answer. Okay, so the assignment that goes with this is mostly just the adding and subtracting. There's some of this rationalizing stuff. There's some FOIL stuff, which is kind of like that. But then we will have a Google Meet on Thursday to kind of go over this, to review, to make sure that our assessment, on Wednesday, so that we're ready for our assessment on Thursday. So I'll hopefully see you then.